Hello everyone, welcome to Technologies Discussion channel. Today, I like to kickstart a new topic of discussion which is on frequency synthesizer. This video firstly, I will define what is actually a frequency synthesizer, what is the key role, what are they actually do in a comms device. Next, I'm going to discuss the three different types of frequency synthesizer. I'm going to discuss the advantage and also the disadvantage when you actually use these three types of frequency synthesizer. This will be the objective of this video. This will be the part 1 series discussion on frequency synthesizer. Guys, I think very soon, I will upload the rest of the discussion on frequency synthesizer. So guys, if you're keen to know more about frequency synthesizer, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on frequency synthesizer. This is my email. If you have any question regards on this discussion, please drop me an email. Or if not, if you want to have a faster response, you are always welcome to ask me through the comment. Before I continue, I'd like to urge you guys to help this channel by like this video. Just take a few seconds. Help me to press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly understand what is actually a frequency synthesizer. A frequency synthesizer is simply an electronic circuit that they actually capable to generate a range of frequency from a single reference frequency, which means that they actually reference to one particular frequency, and with that, they are actually capable to generate a range of frequency. A frequency synthesizer may use techniques such as frequency multiplication. So basically you can imagine that when we actually need to do up conversion, so what we need to do is we can simply by multiply the frequency. We also have frequency division. When we actually have a down conversion, then we may apply this frequency division. Direct digital synthesizer. Fourth method, which is the frequency mixing and also the phase lock loop. But like I mentioned earlier on, so later on, as you can see, we are making use of these three different types of frequency synthesizer. The stability and also the accuracy of a frequency synthesizer's output are related to the stability and accuracy of its reference frequency input. Imagine, the reference frequency actually drift, then the rest of the output will have some so-called cascaded effect. The drift may be even more. So therefore, how accurate, how stable the frequency synthesizer actually mainly fall on also on the dependence of this reference frequency. So as I mentioned earlier on, there will be just one single reference frequency, and we actually rely heavily on this single reference frequency so as to ensure the stability and also the accuracy of the generate frequency. So therefore, synthesizer use stable and accurate reference frequency. Often that is actually produced by a crystal oscillator. So we know that this crystal oscillator, they are very stable and they are actually very accurate. The tolerance is actually very little. So therefore, this crystal oscillator can be a very good so-called device to generate a single reference frequency for frequency synthesizer. Prior to the widespread use of synthesizer, before we actually have this synthesizer, the radio and television receiver rely on manual tuning of a local oscillator to pick up station on different frequency. So imagine radio and television, they actually have different frequency to broadcast different program, different so-called radio broadcasts. So therefore, in order to tune to the desired so-called station, how we actually do it is we have this manual tuning of this local oscillator so as to tune it to the correct station that you actually want to pick it up. So this oscillator use a resonant circuit. So they have a resonant tank. they're actually composed of an inductor and also a capacitor. Okay, a resonant circuit is simply just L and C, either in series or in parallel, or sometimes resonant transmission line. Okay, so basically to determine the frequency, receiver will adjust to different frequency either by a variable capacitor, most of the time will be variable capacitor, or a switch. Okay, switch it at different frequency that basically they select the operate tune circuit for the desired channel. Okay, such as with the current tuner commonly used in television receiver before the 1980s. So basically these are all very old days. Okay, before frequency synthesizer become popular, how we actually adjust the different frequency is by the main tuning of this local oscillator, which consists of L and C. Okay, so basically how you change the frequency, we actually change the frequency with a variable capacitor. So when we actually change the capacitor, the frequency also change. So this is how we actually generate different frequency before frequency synthesizer actually exists. However, the resonant frequency of a tune circuit was not very stable. Variation in temperature and the aging of component cause frequency drift. Okay, I guess you know different temperature actually will have some effect on the component, and because of this, there will be some variation which can be so-called undesired. And moreover, the aging of component also become a key issue. Okay, because the component getting older and older, then this actually creates some undesired effect with a frequency drift. Okay, so this leading the receiver to lose the station frequency. Okay, automatic frequency control (AFC) can help reduce some of the drift. Okay, but manual returning was often still necessary since transmitter frequency are stable. An accurate source of fixed stable frequency in the receiver will solve the problem. Okay, so this is how frequency synthesizer actually born. This how to pronounce quartz crystal. Okay, resonance are much more stable than LC circuit, providing enough stability to keep a receiver in tune. However, a crystal resonant frequency is fixed by physical size. So basically, in short, okay, the frequency is actually depend on the size. So it can be adjusted to tune different frequency. Okay, the different size, okay, of the transmission line, let's say, actually will generate different resonant frequency. And basically, the size actually will control the frequency. Hence, we can't simply just adjust to tune the different frequency. So therefore, one solution is to use multiple crystal. Okay, so which means that we have a lot of reference crystal, okay, each for a specific frequency and switch them as needed. Okay, however, okay, you know that this method, okay, let's say it will only work for just a very simple frequency, which means that we don't need to have much tuning on the frequency, just a few frequency, maybe 3 frequency. I think this method can still work. However, it quickly become impractical and also expensive. Okay, so just give a very simple example for FM. Okay, so basically you need to tune to, let's say, on board on this FM broadcast, we have 100 radio channel, okay, between this 88 and 108 megahertz. Then we need 100 crystal. Okay, so imagine how bulky the FM receiver will be. And also, can you imagine how expensive the FM receiver will be because with 100 crystal. So hence, this is undesired. Cable TV operate over a border range, okay, which means that they have even spaced apart a higher so-called in term of frequency of use for this cable TV. So therefore, they even need more crystal, which add cost and also the space demand. Okay, the solution was the development of circuit that generate multiple frequency from a single reference frequency that is actually produced by a crystal oscillator, a technique called frequency synthesizer. Okay, so this synthesizer frequency maintain the stability of the master crystal. So over here, as I mentioned earlier on, the key definition of frequency synthesizer is they are able to generate multiple frequency from a reference frequency. Okay, so therefore, okay, so this frequency synthesizer actually become a result in terms of many reference for the different clock signal, etc. What is the key function of a frequency synthesizer? Okay, so these are 4 key things that they actually need okay, in order for the frequency synthesizer to function. Okay, firstly, okay, the frequency synthesizer need to generate multiple frequency. As I mentioned earlier on, in the early days, okay, let's say we only have 3 frequency, hence it will be quite easy. Okay, we can still use the resonant LC. Okay, however, in today's world, the comms is getting more and more complicated. So therefore, we need to find a way how can we actually generate multiple frequency from a single reference. Okay, so it can generate a wide variety of output frequency from a mixed reference frequency. Okay, so the rest of the video, okay, I will discuss this. But over here, you can imagine that just one reference frequency, we can actually generate multiple frequency for this frequency synthesizer. Next, okay, basically on the precision control, the output frequency can be very precise control and tune over a wide range. Okay, which means that for frequency synthesizer, the output frequency can be very accurate control. Okay, which means that you can produce a very accurate desired output frequency, and they moreover can tune over a wide range, which means that the range that they can actually tune is actually considered very wide. So hence, this is the desired frequency, desire for frequency synthesizer. In terms of stability, okay, the general frequency are stable over time. Okay, make them reliable for sensitive application such as radio communication. Okay, for example, we need to ensure that the frequency is stable. Okay, imagine when we actually do some comms, okay, then our frequency drift, then the recipient may not be able to receive the signal. So hence, to ensure that the recipient able to receive the signal, the frequency must be very stable. So after that, then this will work for radio communication. Low noise. Modern frequency synthesizer aim to produce low phase noise, okay, a measure of frequency instability over time to avoid distortion in communication signal. So basically, these are the key function, okay, why we need to have frequency synthesizer. Firstly, they are capable to generate multiple frequency from a fixed reference frequency. Next, they are very precise, which means that they are very, very accurate. Stable, okay, which means that they will be, let's say, 100 meg, they will be at 100 meg. Okay, even after some time, they will be still at 100 meg. So basically, they are very stable and they don't drift. Okay, no noise, we actually mentioned about the phase noise for this frequency synthesizer. Hence, these are the key function of a frequency synthesizer. Next, okay, I'm going to quickly discuss the advantage of using this frequency synthesizer. Okay, so the accuracy, okay, they provide high, stable, and accurate frequency, often with very small frequency step, okay, which means that we are able to do some fine tuning, okay, for this frequency synthesizer, and hence they can actually generate a very accurate frequency output. Versatility, a single reference frequency can generate a wide range of output frequency. Okay, so basically they have the versatile, okay, to generate a wide range of output frequency. Stability, okay, synthesized frequency are stable over time and temperature. Okay, even temperature change, they are still very stable. Automation, okay, modern synthesizer can be digital control, enable auto frequency adjustment. Okay, so basically nowadays with technology advancement, okay, especially for the digital one, they can be automatically so-called adjust to produce the desired frequency. Coming to the challenge of frequency synthesizer, okay, firstly on the phase noise, okay, unwanted fluctuation, okay, which means that they can be up and down, okay, for this phase, they actually can cause the spectrum purity degradation, okay, which means that they can have some form of undesired effect, okay, on the frequency spectrum here. Complexity, okay, the design synthesizer, especially at a very high frequency or for a wideband application, can be very challenged, which means that, okay, for frequency synthesizer, okay, so it still has some issue or some challenge when we actually want to operate them at a very high frequency or a wide band, which means that a high bandwidth. So this can be still a very big challenge. The lock time, okay, let's take the phase lock loop. Okay, the time required for phase lock loop based synthesizer to achieve frequency lock can be a limitation in fast switching application. Okay, which means that if you still remember, okay, I have discussed on this phase lock loop. Okay, in order for them to lock, Okay, so basically, this may require some time, and this may be a big issue if the operation need to be a fast switching application, which means that the frequency change drastically, very fast, rapidly. Then we may have some issue when we actually design with frequency synthesizer. In summary, frequency synthesizer are a critical components in modern electronic system, offering precision control over a wide range of frequency, essential for both analog and digital communication system. Okay, so having said so many challenges, end of the day, this frequency synthesizer is a very critical component for any electronics communication. Okay, so before I continue, guys, if you have learned something from this video, please help to like and subscribe to this channel. Once again, thank you so much. Let's quickly discuss the three types of frequency synthesizer. Okay, so first one will be the direct analog synthesizer. Okay, so this synthesizer actually generate frequency using analog techniques such as mixing, filtering, and dividing. Okay, so over here you can see that these are so-called the generate crystal frequency here. So they generate, you can actually mix them. Okay, so after that you need to filter either the upper band or the lower band so that you actually achieve the desired band. After that, in order to step up again, for example, then you need to mix again to another filtering to remove away either the upper or the lower band that you actually desire. So this is what it means. Okay, so therefore this form of synthesizer, they actually use this analog technique. Okay, so you can see from here, they actually have this mixing and you need to have the filtering here. So the filtering will select either the lower band or upper band to pass. And then we also may have some dividing, okay, to step down the frequency or even multiplying to so-called move up the frequency. Okay, the upper frequency is controlled by adjusting the component like capacitor and resistant. Okay, so I didn't draw over here. You just imagine that, okay, all these are actually all controlled by capacitor and also the resistor. Coming to the advantage, okay, so this type, they actually has a very fast response time, and they also have a very desired low phase noise here. Disadvantage, this can be a very complex design. Just take a look. A very simple frequency, you can see that this form here, okay, you can see that the complexity is there. And also, it's also less flexible as compared to the digital method. Okay, so this is the first method, okay, the key types of frequency synthesizer. The second one is actually a newer one, which is the digital synthesizer. As you know that most of the thing we actually move from the era of analog to digital. So basically this is also a newer types of frequency synthesizer. Okay, in direct digital synthesizer, a digital waveform, okay, usually a sine wave, is actually generated by reading value from a lookup table and convert them into an analog signal using a digital to analog converter, DAC. Okay, the frequency of the output signal can be precisely controlled by adjusting the input parameters. So basically, in short, for digital, okay, synthesizer, you actually have this lookup table. Okay, when you actually have this lookup table, you actually were using the so-called reading value to generate the output frequency. Okay, so basically this is the newer method. Okay, so later on, okay, I will have some discussion how we actually have this form of direct digital synthesizer frequency synthesizer. Coming to this form here, the advantage is high frequency accurate. Early on, okay, for the early on method here, you can see that, okay, basically most of the time they work at a lower frequency because you are using capacitor, inductor, etc. So they mainly work at a lower frequency. Okay, but for digital, you actually can have a higher frequency accuracy and we can easily tune, okay, and also integrate into digital system easily. Coming to the disadvantage, we have a limited output frequency range, okay, which means that the range, okay, from the lower side to the upper side, okay, we may not have some desire in terms of the range. We also have some moderate phase noise. Okay, so basically this is the second key types of frequency synthesizer. The last one is actually the phase lock loop. Okay, so basically this is the most popular frequency synthesizer now. Okay, the phase lock loop based frequency synthesizer use a feedback control system to lock the output frequency to a reference frequency. Okay, by adjusting the division ratio of frequency divider within the loop, various output frequency can be synthesized. So basically, in short, over here, you can see that we can actually have this so-called, we actually move up the frequency or move down the frequency based on this phase lock loop. Okay, so I have done some discussion on phase lock loop. Okay, I will put the so-called the link under the description also. Okay, when we actually design the frequency synthesizer using this phase lock loop, the advantage is we are going to have a wider frequency range. We definitely going to have a good stability. Okay, because they actually lock. You can see that they actually have a form of lock. So therefore, we have a very good stability, and they are mainly used in most modern communication system. Okay, so basically, this form of frequency synthesizer is actually gaining more popular now. So basically, I would say that most of the frequency synthesizer in the modern day are actually made of phase lock loop. Coming to the disadvantage, they actually have a slower response time as compared to the direct digital method. And so, okay, we also need to have a more complex design, especially at high frequency. Okay, next, let's come to the last slide, okay, which is on the application of frequency synthesizer. Okay, as I mentioned that there are actually more than this. Okay, so in terms of radio communication, okay, they ensure stable and tunable transmission and reception frequency. Radar system, they allow generation of high-frequency signal with precision. Test equipment can use in signal generator to provide accurate test signal. Mobile phone and GPS system, they actually provide tunable frequency for communication and satellite navigation. In summary, okay, a frequency synthesizer is critical for generate a stable and precision and tunable frequency which are vital for modern electronics communication system. Okay, with this, I'd like to end my discussion. Please help to like and subscribe. Once again, thank you so much for your strong support. I hope to see you guys soon. Bye for now. Thank you.